welcome to this video presentation on New Normal Chemistry Curriculum Orientation. I am Bhojraj Rai, working with the Department of Curriculum and Professional Development. In this video, I'll present on overview and structure of the curriculum, competencies, teaching learning approaches, and finally, assessment. This is the overview and the structure of the new normal chemistry curriculum, which talks about the background, goals, key competencies, guiding principles, strengths, and key stages. In the overview and the structure, let me talk about the background. Science curriculum in Bhutan started with the curriculum adopted from India. In 1986, this was replaced by localized science curriculum founded on the principles of near approach to primary education, that is NAEP. In 2001, this localized curriculum was revised to enhance the quality. In 2008, there was a major reform in PPT-12 science curriculum to make learning science more relevant to the changing times. In 2019, the Royal Education Council initiated science education reform based on its STEM approach to learning science, which new normal chemistry curriculum is the outcome. Now let me talk about the goals of the curriculum. The first goal of chemistry curriculum is to help learners develop scientific reasoning and understanding of science, particularly chemistry, as a lifelong skill that help understand the world around them and make informed decisions. Second goal is apply scientific principles of science, particularly chemistry, to solve common day-to-day issues. The third goal is it helps learners develop skills required to succeed in higher studies and for the world of work. And the next goal is develop and apply the skills of problem solving through design-based learning, engineering design, and engineering challenge. The key competencies in chemistry curriculum are spirituality and values. How does chemistry curriculum contribute towards enhancement of spirituality and values? Chemistry is all about searching for an answer with investigation and experimentation, with integrity and honesty. Therefore, chemistry education contributes towards promoting spirituality and values in students because spirituality is also about integrity and honesty and finding beauty in oneself. The second key competency is language development. There are many scientific terms in chemistry which help students improve their scientific vocabulary. The other one is the transversal competencies, which are critical and innovative thinking, interpersonal skills, global citizenship, enterprising, and industrious. This can be developed through project-based learning, problem-based learning, and design thinking skills. Next is sustainable living. Sustainable living can be promoted through green chemistry. So we have a chapter on green chemistry. The next is health, safety, and well-being. Knowledge of health, safety, and well-being can be promoted through the knowledge of chemistry. For example, knowing the components of certain consumer product may help us to identify the chemical components in the product that can be a potential health hazard. Next is digital competence, use of technology to perform tasks, solve problems, and communicate and manage information. Next is the knowledge and understanding. We observe the phenomena, facts, patterns, and use of scientific theories to construct new knowledge. Next is skills and processes. The skills and processes, and there are some of the skills and processes are scientific thinking, scientific investigation, practical work, problem solving, decision making, information handling, communication, collaboration, and self-directed learning. Next is values and attitude. Chemistry promotes sustainable use of resources for harmonious living in society. Now let me talk about the guiding principles. There are many guiding principles in new normal chemistry curriculum. The first one is Developmental appropriateness. It is based on the theory of stages of learners' development. Second is learners and learning. This is using their past experiences, beliefs, myths to promote learning of chemistry. The third one is teaching for constructing knowledge. This supports the learner to use scientific skills to explain certain phenomena and construct new knowledge. Next is effective pedagogy. Students are provided with hands on learning experiences through project based learning, problem based learning, etc. Next is language learning. Students are provided the opportunity to learn scientific terminology to improve their scientific vocabulary. Next is knowledge and understanding. Students are provided with the opportunity to develop scientific temper and scientific skills to solve daily life problems. Next is the culture and value. Students are provided the opportunity to learn chemistry in the context of one's own culture, values, and belief system. Next is the community involvement. Students are provided the opportunity to learn from the community by involving the members of local community in teaching and learning of chemistry. Next is the local knowledge. Students are provided with the opportunity to learn in their own local context. The next is the chemistry and gross national happiness. Students are provided with the learning opportunity to promote sustainable living, which is one of the essence of gross national happiness, and enable them to live in harmony with the environment. Now let me talk about the strands. There are basically two strands. One is the process strands, which is working scientifically, like questioning and predicting, planning and conducting investigations, processing and analyzing data, information, and communication. Next is the conceptual strand, which is also called content strand. In the science curriculum framework, conceptual strand for chemistry is material and the properties. And under materials and properties, the conceptual strands it provides basis for understanding the physical universe we live in, study about matter and its properties, understand how to collect, organize, and interpret chemical data, develop analytical and problem solving skills. These are some of the goals of chemistry. Now, next is the key stages. Chemistry curriculum starts from key stage 4, that is class 9 and 10. What is the aim of this key stage 4 chemistry curriculum? It helps learners develop basic knowledge and understanding of the concepts of chemistry and the fundamental skills, discover a wider range of scientific ideas for greater depth in chemistry. And for key stage 5, that is for class 11 and 12, to develop knowledge and understanding of the concepts and the skills needed for real life situations. Now let me talk about the competencies. Now when I say competencies, it's key stage wise competency based standards. So I've given an example for key stage 4 under the theme classifying materials, and this is the key stage wise competency based standard. Then I've also given an example for the same theme classifying materials for key stage 5, that is for class 11N. These key stage wise competency based standards are linked to class wise competencies. So under the same theme classifying materials, and the standards are linked to these class wise competencies. These are the class wise competencies for classifying materials linked to key stage wise competency based standards. And these key stage wise competency based standards linked to class wise competencies, which are ultimately linked to objectives for the same class, for the same theme, and for the same topic here. And how does this learning objectives and learning competencies, class-wise competencies, as well as key stage-wise competencies are linked to instructional guide? So your instructional guide contains suggestive learning experiences to achieve the objectives for contact teaching, So these are what you find in your instructional guide: learning experiences for contact teaching, for regular situation, for normal situation, and also instructional guide contains suggestive learning experiences to achieve the objectives for non-contact teaching in case of situations like lockdown, etc. So I have non-contact teaching here, learning experiences in the instructional guide. Instructional guide also contains suggestive assessment ideas and strategies to achieve the objectives. And you have assessment for contact learning as well as for non-contact learning. The next is the teaching learning approaches. What kind of pedagogies or approaches are adopted in chemistry curriculum? We have place-based education. This is to immerse into local culture, heritage, ecology, social and economic as the context for an experiential and real-time engagement. Then the next one is the dimension of effective pedagogy, that is 21st century skills and pedagogy for experiential learning. And the next is the autonomy and flexibility and adaptability. So freedom on how, what, when, and where they learn. And therefore, we give autonomy of choice to learners. Next is reflective practices, thinking deeply about our own experiences and learning from it to improve our future practices. Next is the blended learning. It's a combination of traditional classroom-based learning method with the digital technologies. Next is differentiated, inclusive, and personalized instruction. This is to diversify teaching styles to align with the students' learning styles. All children learn in different styles, and therefore, we group the students by shared interests, topic, or ability for assignments, assess students' learning using formative assessment and diverse assessment techniques and tools. Then use of information technology, ICT and multimedia tools in information to motivate visual and auditory learners. Then use of assistive technology. This is particularly important for children with learning disabilities, and this provides equal opportunity for learners with disabilities. Next is individualized learning, that is facilitate students establish learning goals based on their personal, academic and career interests. Next is the laboratory investigation. This is very important in science in general and chemistry in particular. This laboratory investigation actively engages learners and helps them to develop scientific skills. The other one is the claim evidence reasoning, which we call CER. It helps learners develop better understanding of a problem and gives the ability to communicate the thoughts clearly and scientifically. Next is process oriented guided inquiry learning, which consists of students working in small groups. Next is a process-oriented guided inquiry learning. It is a student-centered instructional approach which consists of students working in small self-managed teams on especially design guided inquiry materials. Next is project-based learning. Here, learners acquire a deeper knowledge and skill through active exploration of complex questions, real-world challenges, and problems. Next is problem-based learning, learning that involves groups of students working to solve a real-world problem, quite different from the direct teaching method of a teacher presenting facts and concepts about a specific topic to a classroom of students. The next is 7E method. In 7E method, it provides learners with opportunities to actively participate in learning process and master the competencies. Next is the divergent thinking. It is all about generating multiple ideas and multiple solutions to a problem. There is no single solution to a particular problem. It can be approached through multiple ideas and multiple solutions. It is a process of seeing a lot of possible answers to a question. And next is design thinking. In design thinking, it considers all the creative problem solving through the lens of human-centric design or human-centric approach. Next is backward design, and it's a strategy used to design learning experiences and instructional techniques to achieve specific learning goals. Now, finally, let me talk about the assessment. We assess on three domains. They are basically scientific knowledge, working scientifically, and scientific values and attitudes, which are knowledge, skills, and values and attitudes. Assessment techniques and tools. These are suggestive assessment techniques and tools. Assessment techniques are practical work, projects, journals, model making, which are very suggestive. And also, suggestive assessment tools are checklist, rubrics, rating scale, and marking scheme. We have also suggested digital assessment tools such as Google Forms, Kahoot, and Padlet. Now, when it comes to assessment structure, for Key Stage 4, that is for class 9 and 10, continuous assessment consists of 40%, which is 20 plus 20, 20 in the first term and 20 in the second term. And written examination is 60%, which is 30 in the first term and 30 in the second term. Similarly, for Key Stage 5, that is for class 11 and 12, we have 30% CA, which is 15 plus 15, 15 in the first term and 15 in the second term, and 70% for written examinations, which is 35 in the first term and 35 in the second term. Now, these are further broken down into these columns. This is for term 1 and this is for term 2. And also suggested CA breakup, continuous assessment breakup are also suggested, like assignment and class activity and test and project. And continuous assessment breakup also similarly suggested for term 1 as well as for term 2, both for Key Stage 4 as well as for Key Stage 5.